Hello everyone. Let us start from the problems where we stopped last time. So we are learning data analysis and data mining by using Python. I think we completed a problem up until 28. Okay. Now problem 29 is telling in the dataset D2 data, there are variable SBP and DBP, which stands for systolic and diastolic blood pressure. We want to find the average of these two variable and want to create an average blood pressure. In reality, this ABP does not make sense. So we always take decisions from the systolic and diastolic blood pressure. By averaging these two blood pressure, if you create a average blood pressure, that will not have any medical meaning. So medical science would not accept these things. Okay. But what we are learning here, we are learning here how to find the average of the entries in two columns. That is what we are learning. So here SBP and DBP is our variable. I know that I consider them as initial and then finding ABP by finding the median of that. So for the two variables, median, for the two values, median is just the average. So that is why I write here median instead of mean. And then finally, I want to see them all together. So that is why I put SBP, DBP as well as ABP. And finally, I want to see them. So if someone take the average of these two number and divide it by 2, then he will find that which is equal to V plus divided by 2. So we see 93.25. Here is the 93.25. So this is the average of these two numbers. So what we have learned from here, how to find the average of the entries of the two columns. Sometimes down the road in our life, we might need to find this thing. So this is the way to write the code. Now, these ABP values, based on these ABP values, I want to find a categorical value. For example, if greater than 100, then category equal to 1. If less than 100, less equal to 100 and greater than 85, then 2. If less than 85, then 3. That is the categorical variable I want to create from ABP. So if we take a look at the question number 30, on that question number 30, it is said, create blood pressure category variable from the ABP values. That ABP values should have numerical values lies between like 80 to maybe 140, something like that, or some higher values like that. But I want to categorize this. So 1 stands for ABP values between 100 and above. 2 stands for ABP value between 85 and 100, and 3 stands for all other ABP values. So in this case, we want to find a limit. So in this case, take a look at that. This is just the highest limit I am finding. D2 ABP and maximum value of ABP is in here. And with this maximum value, I am adding in here. So it is making sure that no values from the ABP will be out. So no values, highest limit. So now after doing this, take a look what I am writing. 0 to 85, category equal to 3. 85 to 100, category equal to 2. And 100 and above, ABP limit equal to 1. So this is the four ranges, range 1, range 2, range 3. And this is the corresponding labels. So I am creating this blood pressure category variable and want to see that. So this is the blood pressure category variable. This is the ABP, average blood pressure, which we obtain by finding the average of SBP and DBP. Okay, after doing this, now I want to subset the data further. How to subset the data for a range of values of variables. So I want to find total cholesterol value is greater than 162 and weight values is less than 62. So based on this, we want to create this data says D21, which has the TC value, total cholesterol value greater than 160 and weight value less than 62. Okay. After this, now we want to find the cross tribulations. That means frequency of the BPC categorical variable. BPC means blood pressure category. I want to see the frequency corresponding to one, how many frequency corresponding to 3. If we run it, we see corresponding to 1, we have 716, corresponding to 2, we have 1100, corresponding to 3, we have 126. Okay. So after this, then alternative approach is just this one. Same results we are getting in different order. So the line number 183 provides the output in terms of the highest to lowest frequency. Now question 33 is finding the cross tabulation or joint frequency table of the two variables, which is raise and BPC. So this is the joint frequency table for the BPC and raise variable. And question number 34 is asking you finding the mean and standard deviation for all variables corresponding to race variable. So that is why there are two races, and then we are finding mean for the race. For income has a mean for race 1 and mean for race 2. Age has a mean for race 1 and race 2. That's the way we are finding the average and standard deviations by race. And similarly, we are finding the mean and standard deviation for a specific variable. So instead of complete data frame, if I want to focus on finding the mean and standard deviation by race category for a specific variable, so line 197 and 198 will give us the desired results. Question number 36 is asking you find the variance of the income variable. Find the variance of the dataset by income variable. So find the variance of the dataset by income variable. Okay. And then question 36 is asking find the variance of the SBP variable by income. By income, we want to find the variance of the SPV variable. So income is 9 level, so we will get 9 variances corresponding to each income level. Okay, so now I want to do the question number 38, which is dropping duplicate values. So we should have we should not have any duplicate values by ID number. If there is a multiple IDs, like same ID is appearing multiple times, we will take only one. For example, take a look at the D2 data, np.shape, and then I put here D2. And then I want to write here like this. Take a look at that 1440. We have found that does not have any repeated measurement. Okay. After that, now we want to do some visualizations. First one is we are trying to do pie chart for the smoker variable. So here is the pie chart for the smoker variable. So in this case, by running the line number 215, I found the frequency of non-smoker and smoker. Our smoker is 47 and non-smoker is 1993. I choose the color red and green, and then finally we got the pie chart, and you have seen in the pie chart that red part is coming out from there. In order to stop it, if we take out this explode part, for example, if we take out this explode part, just comment it out in there. Just comment it out in there. And then if we write it in here, so that explode part is gone now. It is not seen in here. Okay. So that's the explanation of the what explode part do. So I can take this out from there. So now I want to see the bar chart for smoker variable. You see non-smoker is way smaller corresponding to the smoker. Okay. So bar chart and pie chart are the chart for categorical variable, and box plot and histogram are the chart for the quantitative variable. So after doing this, we want to do pie chart for income variable. There is a rationale for showing you pie chart for the income variable because income has a 9 levels. So that means I want to put 9 different colors. So in order to show that what are the 9 colors I'm going to put, I have also provided a link from where you can choose other color as well. A lot of colors are in there. So this is the pie chart for the income variable. So let me find it, then import this, then go there and go there, go there. Let me put all of these things together. I don't know why color is not shown now. Previously, very beautifully color was. Why color has been destroyed completely? Let me see. Let me rewrite all of these things again. Is this labels? Labels. Labels, labels. Labels. Why is not giving us the same result as I got it previously? Well, I don't know why the color is not showing up in here, but previously when I did these things in the morning, I found that the color was showing. Okay. Anyway, this is the um, pie chart for income variable. Let me check whether this one will work or not. This one is working. Why that one is not working is weird. Colors. Mm, Oh, I got it now. I forgot to put that in here. Now you will see in the pie chart, colors will be in there. Now in the pie chart, colors is in there. Okay. 42 I have shown. Now I want to show the question number 43. I want to show the question number 43. I have shown pie chart and bar chart side by side. Pie chart and bar chart side by side. 44. Pie chart and bar chart for race and smoke variable has been shown. Here is the race. Here is the smoking. Race and smoking variable, pie chart and bar chart are shown in 2x2 grid. Question 45 is showing you stack bar chart. Stack bar chart. And question 46 is showing you group bar chart. Group bar chart. And then question 47 will showing you group and stack bar chart together. We want to see that graph together. Okay. Now we want to find dot plot. Dot plot means if there is a continuous variable and by observation number, I want to see the plot of that variable. That is what called the dot plot. This is called the dot plot. What happened? Because we did not call. This is called the dot plot. I'm subsetting the DBP variable by race. So one DBP for race 1, another DBP for the race 2. This is the SBP. Two histogram for the two SBP, one for the white and one for the black. Similarly, box plot for the complete data. Now box plot. One box plot for the white and one box plot for the black. Now we have done one dot plot for complete SBP, one dot plot for the African American, one dot plot for the Caucasian American, one plot for the all African American and Caucasian, second dot plot for the African American, third dot plot for the Caucasians, one histogram for the all, another histogram for the African American, another histogram for the Caucasians, 6. And then one box plot for the all, another box plot for the African American, and another box plot for the Caucasian. So these 9 plot we will do for the 9 plot for 9 plot we will show in a 3 by 3 grid, in a 3 by 3 grid. So this 3 by 3 grid will have all 9 plots. Here is the all 9 plots. Then Q55, question 55. Construct pairwise plot of the SBP, DBP, TC, TZ. These 4 variable, we want to do the pairwise plot. In that pairwise plot, that means SBP and DBP, there will be a dot plot. SBP and SBP will be histogram. DBP and DBP will be histogram. When the pair is matching, then there will be histogram. If pair is not matching, then there will be a dot plot. Pairwise dot plot in question number question number 55. This is known as the pairwise plot. Pairwise plot. So this is the histogram for the SBP, histogram for the DBP, histogram for the TC, histogram for the triglyceride. Rest of them are pairwise plot. For example, this one is the plot of SBP and TC. This one is the plot for the DBP and let me see, SBP, DBP. SBP, DBP, TC. So this is the DBP and TC. And that is a DBP and TC. Okay. So now we want to do box plot for different box plot for a continuous variable for different values of a categorical variable. So in this figure, we see there are 9 income level. For each income level, we will have a box plot for SBP. For income level able, for income level 1, the box plot for SBP. Income level 2, box plot for SBP. This is the box plot. Okay, after that, we want to do question number 57. I want to take a sample of size 200 from the data frame. So question number 57 is telling you to take a random sample of size 200 from a data frame, which we did. Okay. So, and then question number 58 asking you take a random sample of size 100 from a variable. Instead of a data frame, in question number 58, we are taking a random sample from a variable. After getting that sample RS, we want to construct Stemlich plot. So you must need to install following from the command prompt. Pip install stem graphic. These things you have to install from your command prompt. How can you get the command prompt? Command prompt you can get if it will not work smoothly in your computer, then go there and command prompt and put it in there and hit like this. Okay. This is called the command prompt. How can you go to the command prompt? Just click in there, then a black command prompt will appear. You can do this. Okay. Another approach, you should go to Anaconda and hit in CMD executive prompt. If you click in there and then just hit it in there, and then wait in there, it will be installed. Without running these things either in the Anaconda CMD executive prompt or in the command prompt in search bar down part, you would not be able to run this code. Okay. So now let me take you there. I have imported these things. Now the sample of size 100 that I took from SBP will be used to construct stem-leaf plot. Okay. Why they are not giving you the result? Let me just check in there. Did I do that? Pip install. Now let me see. It was working before. Let me see whether it will work now. Wow. I don't know why it is not working now. Previously it was working. Stem graphic. Pip install stem graphic. Let me install it from there. Command prompt. Pip install stem graphic. Let me see now. Okay, now we see that stem leaf graph is shown. So stem leaf graph means in a number, they will take non-decimal number as your stem and decimal number as your leaf. That way they can construct stem leaf graph. So question number 60 is asking you, take only, question number 16 is asking you, subset the original D1 data by these variables and denote this new data as a D4. So this is just a subsetting of the original D1 data. So this is the, I want to keep. So this is the variable we want to keep. So we want to check the shape of the data. And then we want to find number of missing values corresponding to each variable. And then we are creating a column missing in the default data, which has been created. D4.head. D4.head. Then we want to delete any row that has a missing value should be deleted. I'm creating now new age variable by rounding current age to 1 decimal place. And then I am subsetting the new age values must not take less than 9 and less equal to 9 and less equal to 19, must not take less than 19, and must not take greater than 19. Must not take less equal to 19. Okay. So this is the way data subsetted. After subsetting the data, our purpose is to export the data. So D5 is the data which is subsetted, cleaned up, missing values deleted. Now the data is ready. And as a data manager, now I want to give this data to an employee so that he can do further works. Okay, so that he can do further works. So I created the data which is D5 by doing lot of manipulation. Now I want to save the data or export the data. I have exported and saved the data, which has named D5. How can I find that? Just right here, D5. So this is the data has been saved. Where it was saved? It was saved in the same directory where I created at the very beginning, okay? Which I created at the very beginning. So check the dimension of the new D4 data. Then 67 is asking expo split D5 data by new age variable and denote by D6. D6 will be a list which had multiple data. So now we want to do 67. This is my 67. And by running the code line 568 up until 573, all of this is showing you what data we are looking at. Are you saying, is it saying 19 and then A is equal to 19? If it is said 11, then A is equal to 11. And 15.5, that means 15.5 age will be. Corresponding to each age, ranging from 9.1 to 19, we would have a one data now. This is the I'm checking the length of the D6 data, and then I'm trying to find like the 69. I'm trying to find the dimension of the data. Here is the dimension of the data. This is the total data points. This is the single loop. DS equal to rows for rows in D6, because this is the data which is split by the new age. So I have to find this mean SBP, mean DBP, mean height, mean weight, mean BMI. And finally, if we write this, we got that result. Okay. This is coming from PD like this. This is a data. This is the output, because we want to get the result without for loop, right? Without for loop is this one. So question number 72, we have 12 more problems. Reduce the things from question 70 and 71 without using for loop. So without using for loop, how can I do that? Without for loop. So this is the way data has been splitted by new age. And then I just run it. We are getting the same results as we are expecting. So this code does not make sense, but anyway, I just want to keep it. This is for not each split data. This is for the complete data, because we are looking for 4 different quantities. 1, 2, 3, 4. Okay, now question number 73 is speaking 10 rows and 10 columns from D5 data and finding the grand mean of the data. Now we have a original data that is 10 rows, 1, 2, 3, 4, 10 rows and 10 columns. And then now we want to do what? We want to subtract the grand mean for each entries. So that means it is a 10 by 2 or 10 matrix. I can go by row and row column. That is why I for row, J for column loop we have to run. After doing that, I'm running all of these packages and then running these calculations, double loop, 10 rows and 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This matrix should go like this way, but for some reason it got split. So without double loop, we can also compute these things in that manner. This is the another way to compute double loop. What happened? D4 is not obtained. So question number 76. Long format data become wide format data. And question number 77. Wide format data become long format data. This is what we have learned. And then question 78 is asking you put some 10% missing value. This is what we have done in here. There is a function and missing. There is actually a columns, and then by using these columns, they are creating a function which we are going to use it. So 79, we want to do the job again. What job we have done? We declared the data location data path, and then we took 4 variables and n1 equal to d1 columns and copy 80. Console is here. So they are going to merge two data in question 81. So doing this, we merge two matrices. Uh, yes, 80 and 81, we may merge matrices two columns. Now 83, is question. Take a random number of 1000. Take a random sample of say 1000 cards from the first 10,000 cards in D1. Denote this as a M1. Okay, the next two are like um, one is marked at the bottom of the other. That is what like another one. So all the problems that we have done in here cover data analysis and data mining problems. And if you practice these things multiple times, anyone wants to write you a code, you can immediately write the code in the Python. Python and R is very essential and important to learn. I think the expertise on these two programming languages will beneficial for you to get a job or to apply for graduate school. Thank you very much. That's it for the second week.